Hello all, let us talk about something called race condition in embedded systems. So race condition is something which is undesired scenario that happens due to hardware, or it is due to the software that is written for a particular system. Let us see what is race condition from the hardware perspective. Like in the hardware, let us assume we have a IC for which there are two inputs, input 1 and input 2. Let us assume the output of this particular IC is depending on the input states. Okay, so let us assume this is a simple AND gate. Okay, so in the AND gate, if you see what happens is when you give 0 0, okay, you get 0. When you get give 0 1, you get 0. When you give 1 0 on inputs 1 and 2, we are talking, and this is output. Okay, we get 0, and we give 1 and 1, we get 1, right? This is the condition in AND gate. This is the truth table basically. Okay, this is the output. Now in this scenario, let us assume we are having a 0 and we are having a 0. So this is actually coming from a source. The input is coming from a source, right? So this can be from one input and this can be from one input. Now let us assume these are traveling from another chipset on a board, okay, on the same board from another chipset, and let us assume a condition initially that it is 0 0 and the output is 0. Now we have given 1 from this chip to this on this pin and 1 from here. So initially it is 0, and then initially it is 0, output is also 0, and once the input on one goes high, so this also should go high at the same instant, right? And then the output also goes high. Now let's assume a scenario where the input on 2, which we need to give 1, arrives at a little later time, like this is 1, and let's assume this is another input which is coming here. Okay, for this particular time, right, the output of the AND gate stays low and then it goes high here, correct? So there is a timing, particular timing for which the output is not in the um, desired state, where 1 has already gone high, 2 hasn't gone high, because the output stayed in low condition. This is just a simple case by taking an AND gate, but this could be a scenario that could happen in any of your circuits due to the timing issues. So especially in the high speed signals, what we do was we do length matching of these particular traces to ensure that we avoid these conditions. Okay, even for low speed signals, we have to ensure that there isn't a too much of length variation from one signal to another, such that that small timing for which the output is not valid condition should not occur, right? So let us assume a scenario where this is going to another system as a clock or some edge triggering what is happening. Now, with this scenario, it might give a wrong input to that particular device or IC, and you might have improper functioning of your system. So, a clear explanation of race condition, right? Now, this is about hardware. Firmware race condition also is common. Like what happens is, let us assume we have a block of code which is executing, and there is one more block of code which is executing, and which is, let us assume, is changing a common variable or something. Now, because of execution of one code and execution and at the same time the execution of another code happening at the same time, because of difference in execution between these two, let us assume this variable state changes to a different way state. Like let us assume we are changing between 0 and 1. So if it is 0, because of these code differences, suddenly it might go to 1 once and then again come back to 0. So these cases generally happen when we are using variables in global variables in different functions in the codes. A very very common scenario, and especially race conditions could occur when we are doing the memory operations. Okay, so a very important scenario to be considered, right? So these race conditions are basically three types. One is called static race condition, and the other one is called dynamic race condition, and the third one is called essential race condition. Now, commonly in these scenarios which we see, right, with the indicate case where you are giving, so this basically is a dynamic race condition, where due to the difference between transition timing difference between two signals transitioning to different states at the input of a particular IC happening is a dynamic race condition. Static race condition is very very simple, where you have one signal and we have the same signal negated and provided to a particular chipset, which is causing a race condition. That is one more scenario. So in those scenarios, it is important that we have to bear with those conditions, because there is a condition that we know that is happening. But in this dynamic race condition kind of scenarios, we have to eliminate those delays, and these delays are not just related to the PCB trace length difference, right? There could be some other devices in between, like buffers or some mux or some level translators, which are also causing some delays in the hardware. So even those conditions, those ICs data sheets need to be thoroughly read and seen that we apply the same rules in the PCB path or same circuits in the PCB path, such that the this condition is avoided. A very very important scenario which need to be understood by the hardware engineers. So these race condition normally happens without getting noticed, and only once it occurs we get to know that there is a problem. So designers need to keep this as one of the checklist in their items to ensure that there is no race condition existing in the circuit, so that this cannot be, this can be a preventive action rather than a corrective action.